I am a software performance analyst with IBM Canada. Previously, I was a software developer with DB2 database systems. And for the past 6 years or so, I've been looking at how software works on IBM Power systems. Power is one of the, yes, everyone knows Intel. Intel is a predominant processor architecture out there, from low-end small system, well, I guess medium small systems to the high-end large high-performance systems. So Power is the alternative architectures for the medium high-range systems. And with the latest iteration, IBM Power 8 processor, in 2013, they open source essentially everything about the processor, from the chip architecture of the supporting chips to the process architecture, and even made the firmware available. So for those people with enough interest or enough money and enough time, they can license every bit of the chip design, go to fab, well, modify, go to fab, produce their own chip, download the firmware directly from GitHub, modify whatever they need to modify. Suppose they have a very specialized application, and build it and go on up. So that is what OpenPower is. OpenPower is a foundation with a large number of technical partners, and they all contribute to the design of it. So it's a hardware technical foundation. So whereas you'll hear about Apache in the keynote next, it's about software foundation. This is OpenPower is a hardware foundation. So sorry, well, hardware technical aspects, and that is, and because it's hardware by itself is not very useful. So on top of that, you have to make software available for it. And that's what IBM has spent, IBM and its partners spent a fair amount of time enabling that. So, also in addition to the OpenPower, which is the open source aspect, there's also the IBM branded Power Systems, which runs AX or Linux or whatever. And that is not open source. So there's the open source firmware, bootloader, all the way up to the operating system. And then there's a closed firmware, bootware, all the way up. So for enterprise customers who require a bit more control over it, there's the lockdown version. But when you buy an open power system from IBM or any of the vendors out there, I think there's half dozen companies producing open power software, like open power systems, that completely independent of IBM. For example, Red Power in China has its own fab. They licensed the chip designs. They made some modifications to it. They produce it. They're selling it within China. So I think the market is predominantly within the Chinese market, so you won't see them here. But they are available, and they've essentially done their modifications to whatever they need to do. So, but OpenPower, unlike the IBM closed systems, OpenPower systems essentially right now only has one operating system, and that is Linux. So Linux, as the top line says, is Linux is Linux is Linux. And the goal is to enable people to develop software more easily on OpenPower. They want Linux to look and feel the same way on Intel, ARM, Power, Z is IBM mainframe systems, the old MIP systems, etc. So the main Linux distros have all been supported on Power, and the ones that we've used are Fedora, Red Hat, Ubuntu, and Debian, SLES, and CentOS. So I guess 3 of them are based on Red Hat, but pretty much everything is available. Interestingly enough, during the design, the pre-release part of the OpenPower systems, Red Hat was asked about providing operating system support, a port of Linux for little endian for OpenPower systems. And based on what their previous experience was porting to the previous version of Linux for IBM, they figured out a couple years. So in 2014, a couple years will bring us to present day. There was a lot of panic going on. Like we have a system with no operating system, which is pretty much useless. But Ubuntu, so that was their design, their power scaling. But Ubuntu came along, or Canonical came along, and decided to attempt to port it. So there was a lot of people, manpower spent on just the basic operating systems, basic packages. And Ubuntu was able to port roughly 40,000 packages for Linux in 5 months' time. And shortly thereafter, Red Hat came when they realized, whoa, Ubuntu did it with very low manpower, be able to essentially port Linux from Intel systems to Power systems in a few months' time. So, and also other companies such as Google have ported almost essentially all of their software to OpenPower systems. Google had attempted to port their software to the previous versions of Linux on Power, and they were having a huge amount of difficulty with it. Mostly because the endianness have changed, not all the software packages are available, so they had to use different versions of software packages, different names. The functionality was there, but the package names were different, and it was just a lot of effort to go through and find and fix all these errors. But with the advent of OpenPower, and the fact that everything that you see on Intel Linux is available on Linux on OpenPower systems, they were able to port it very easily. So, but Google's main goal, although they've demonstrated everything works on Power 8, they're waiting for, in particular, the next iteration Power 9, which is due out, I think, next year. So some examples of open source packages that are available on OpenPower, like all the main NoSQL databases, some SQL databases. So we have full stack of web servers and app servers, and basically cluster management as well. So essentially, OpenPower systems as it is, you can buy it and set it up and use it as a cluster using completely free open source software. And I think that the cheapest system I've heard of, if you want to get into OpenPower, is like $2,500 US. So it's significantly cheaper than the $20,000 US IBM Power systems. So it's entirely possible with the price of essentially the same price as an Intel server to use OpenPower. So some of the other software packages that have been ported and people are running on OpenPower, here's a fairly broad example. We have the high performance computing examples on the left side from, I'm not sure what all those are. So with cloud, my role is predominantly in big data and machine learning. So I've done a lot of work with Hadoop and Redis and MariaDB. And other people are doing work in the other systems as well. So GPUDB, I think, is something that's been tested lately, and that is basically using GPU accelerators for database operations. That's something that's been tried. DB2 has tried in the past, and they found that it wasn't really performance enhancement. But with Power 8 and soon to be Power 9, that's going to be simply different. Same thing with Spark. So my day job essentially look at looking how Spark and Hadoop and the whole software stack works on OpenPower, and try to analyze and determine the characteristics of it. So, but we have mobile enterprise as well. Large number of packages there. So again, getting Hadoop and Spark. So I've been Toronto Lab is involved a lot with performance. And for example, performance analysis and optimization. For every new release of packages, since the majority of the development currently is on Intel systems, it runs fairly fast or fairly well on Intel systems. So we look at it on Power and look at the unique advantages of Power and, well, what's going on, how can we make it work faster. And an example would be, I guess, Spark 1.6 or 1.6 and 2. When we look at the processing stack, we run it. Spark 1.5, we run the same workload and we're roughly twice as fast. Run it on 1.6, we're like 1.1, and we're like, what's going on? And it turns out that there's a bunch of SIMD instructions that are in the newest versions that are not, that when you run in Power, runs Java versions. So when you run vector instructions versus Java, that's where the performance differences are. So we've identified those, and that goes into our JDK. So that information is fed into the JDK. So the next release of JDK comes out, we intercept that and runs it a bit faster. And there's Spark libraries for machine learning, graph, SQL, etc. And that's also what we do. Try to identify exactly how to make all these existing applications that customers use work better on Power systems. So same with Hadoop. I don't think we've gotten around. We're using Hive now and Pig, but we haven't really gotten around to almost all of this yet. Also schedulers, we spent a lot of time on schedulers. The IBM Power system differs a bit on Intel systems because, well, the newest Intel processors have a large number of cores, and I think way more cores than some of the Power systems have. So I think some of our systems would have 40 physical cores, and I think some of the newest Xeons would have like 44 physical cores per chip. So it's a huge number of cores, large caches, but coordinating all the effort, the runtime is fairly complex. So in order to get fairly decent performance, you need a good scheduler to maintain your workload. And we look at how best to configure the schedulers on the different systems. So, and as mentioned before earlier, machine learning, deep learning, this is something that Google's done a lot of, and in particular for companies like NVIDIA. So Power 8 has a number of, I guess, high-spec I/O capabilities, which you don't find on Intel. So on Intel systems, and that is, I'll mention more of that later. And so there's a lot of work put towards machine learning, deep learning libraries, such as Cyano, Torch, and Caffe. And there are all these packages available. So for people who are looking into that type of application, you can Google the name, you can Google and download it and make use of it. So, but you can code using DL4j on Intel. And for example, if you want to test your application on an OpenPower system, you can just download the DL4j libraries from OpenPower and see your performance differences there. So, so getting back to that about testing, I'm not sure where it is now because I'm not in the marketing side, but there always seems to be some avenue in order to get free accounts on some public cloud somewhere to use OpenPower systems. So it's entirely possible that if you don't have access to an OpenPower system on campus or through a business partner, to get a free cloud-based instance of OpenPower. So I think right here, support for upcoming OpenPower systems. The OpenPower machine they're talking about is, I think it's been released, and that's something that I think a few hundred have been shipped to some laboratory in the US. And it's the technology here is something called NVLink, and that's something that NVIDIA has developed. I think NVIDIA went around and asked Intel and IBM if they were willing to support it. Intel has their own things going on, so they said no. So IBM Power Systems support this NVIDIA-defined protocol specific, and it's basically a new channel to communicate with the GPUs and a processor. And the idea is it's super high bandwidth. So these GPUs these days are incredibly fast, incredibly fast. I mean, I think when I mentioned earlier about DB2, even 5 years ago, the GPUs back then were essentially being starved. You can program what you need them to do, but you can't supply data fast enough to them, so they sit around idle. And so one alternative approach is just give more RAM, stuff more RAM into them. So I think some of the cards we had in-house were 16 gigs of RAM. But when your GPU is processing 300 gigabytes a second, that's no time at all. So with NVLink, and soon to be NVLink version 2 and such, the pathways have been increased. I think NVLink is a couple hundred gigabytes per second. So it allows GPUs to become more efficient, so you can process data more faster. So this particular system has 4 Pascal 100 GPUs. These Pascal 100s, I think, are current top of the line. I forgot what specs on them were, but I think each one of them is faster than like the first Earth simulator supercomputer that used to be #1 on the top 500 list. So you have 4 of these in one server. And we can reasonably supply data to them at a fast enough rate so that they can become useful. And prior to this, you can put that much computing power, but the GPU just sits idle. You can't do anything with it. So, okay, as I mentioned before, there's infrastructure software from the bootloader, OS, hypervisor, containers, and everything, and OpenStack. So it's been supported for quite a while. So as far as everyone's concerned, the whole software stack, from the firmware right up to the operating system, the management layer, as well as whole applications, it's fully supported. So anything you can do on Intel Linux, essentially you can do on open systems, OpenPower systems. But of course, why bother with OpenPower? I mean, if Intel can do everything and OpenPower can essentially do the same thing, it's like me too. Look, so why bother supporting two different platforms if you don't have to, right? So that's why Intel squeezed everybody out, because Intel can do what they need to do. Everyone's happy with it. But there's probably two reasons. I'll give you an example of Google. Google probably, one reason that Google supports OpenPower, and it's something that analysts have pointed to, is one, it's used as a hedge. They can't give Intel all the business because Intel would just squeeze them out. And if Intel has a monopoly, they can dictate the terms they want, pricing, availability. There's no competition for features, things will stagnate. So that's what analysts have said. But being on the software performance side, I like to think there's another reason why Google prefers to use OpenPower systems, and that is performance. Performance is fairly competitive. And we've done a lot of work just check to make sure things run very fast on the OpenPower systems. For example, a lot of the MongoDB, MariaDB database applications, your analytics workloads, and a lot of synthetic benchmarks. So Oak Ridge's National Laboratory and Lawrence Livermore Laboratory, they're taking delivery, they took delivery, currently taking delivery, and will be taking more delivery of new systems. And that's essentially for all their high-end HPC software, including weather, nuclear simulations and such. And I mentioned with Google before, and Tencent, I think a lot of people here may have heard of Tencent. They're a Chinese ISV, and I think last year I'm not sure how much was mentioned. There should be a press release soon about IBM and Tencent, if there's not already, about some of the high performance work they've been doing. And so some of Tencent's workloads, I think they have 8,000 plus Intel servers in their Spark cluster alone. I'm not sure how many servers they have, but their Spark cluster is 8,000 servers. So they've ordered a fair number of IBM Power systems to augment some of that work. And again, the main reason for that is performance. And to get performance on the systems, well, there's a lot of, because the architecture is different, there's a lot of knowledge in terms of tuning. So for example, with multiple socket systems, whether Intel or Power systems, if it's multiple sockets, you have to worry about NUMA effects and everything. But on the easy side, when you're just taking compiler software from open source communities and want to compile it, we have a number of how to do that. So there's an IBM XL compiler, which is, if you were to license it, it's I think thousands of dollars per seat per year. So the flagship the flagship compiler supports C, C++, Fortran, and I believe there's COBOL kicking around as well. And depending on the application and how easy it is for the specific optimization there is on the code to be recognized, it looks to be 15 to 50% faster for high performance computing applications, and that is if it's really math heavy, right? So it also supports CUDA, Fortran, OpenMP for people that are used to coding in for large systems. And of course, there's the math library. That's math accelerator subsystem. Intel has their own math toolkit as well. So a lot of, so a lot of high performance computing systems applications, if you need it, link directly in. So you don't have to link math directly. So once you have your HPC application or math heavy application, it will compile fairly quickly. So, and of course, the community edition is free. So you don't have to pay for that. It's free software, but it's not open source software. And also developed at the IBM Toronto Lab. GCC is optimized at the IBM Toronto Lab. So actually not Toronto lab. I think it's a different lab that optimizes it, and it might be in Austin or California. So they also look at the performance characteristics and try to make, so if you want to compile software on Power, it will also compile as well. And supports essentially what I've done with GCC in the past, because the operating system comes with a basic compiler. I download GCC and I just compiled it without any changes. So it works really well. And as I mentioned, because the patch cycle going from IBM through, the number of committers that IBM permits is fairly limited. It has to be security clearance after the open source lawsuits and everything. People who can look at open source and develop is fairly limited. So if anyone finds issues or performance enhancements, it has to be vetted through, and IBM legal go through, and only a certain number of people can commit things to open source. So that's why having found a performance enhancement could take 6 to 12 months to get out into the community. So GC is a bit slower than IBM XL for news changes, but it's available. And IBM Advanced Toolchain, which is a kit, the whole software development kit, is freely available. So it's for Red Hat and Ubuntu. And just, I'm not sure what this is. So it's an ACC compiler, and that's Portland Group. Okay, it's owned by NVIDIA. NVIDIA has its own compiler, and that's aimed specifically towards their GPU applications. So all the multi-processing applications. So, and as mentioned earlier, there's the math libraries for the HPC things, because with the US government ordering so many systems, we have to support the applications, and all the math libraries is very heavily optimized for OpenPower systems. And Intel invests a lot of money as well into their math libraries. So both systems have very accelerated math systems. So also FPGA, so CAPI attached. CAPI is something I haven't mentioned, but that is I kind of alluded to with NVLink. But CAPI is what everyone here has heard of PCI Express, which is the main interlink for expansions within most computer systems now. So I think with Power 9, IBM is moving with PCI Express generation 4. Intel decided very conscientiously to stick at generation 3, even though they had these massive 44 core or larger processors, which require a lot of data. So IBM is first, and presently I don't know if Intel has any plans to support PCI Gen 4, but so it's this PCI Gen 4, also something called CAPI, which cuts a couple layers off of the whole CAPI stack, software stack, to reduce latency essentially. Reduce latency and increase throughput. So this makes things available, generally possible, such as 100 gigabit network cards, faster GPUs, and there are software development kits available for it. And Xilinx, mentioned here, Xilinx is OpenPower member, which is really doing a lot of driving for this. So I mentioned OpenPower is a large technical organization. Different companies push different things into this hardware stack. Xilinx does FPGA part, as well as some of the CAPI part. NVIDIA clearly does GPU and NVLink. Companies like Micron is pushing new memory technologies, so phase change memory will be available on OpenPower as its plug-in, and eventually it will be available on Intel, but Intel hasn't, I don't believe, has made as much commitment towards it as Micron to OpenPower systems. So for those of you who are not aware, phase change memory is non-volatile main memory. So you can just plug it into your system. If you power on and off, the data is still there. So the goal of that is reduce boot times or whatever if your system goes down, and reduce power requirements as well. So also this large IBM SDK for Linux on Power. And again, it's free. I guess if a lot of people use Eclipse before, it's Eclipse based, and supports essentially all the tooling and everything I mentioned before out of the box. So the goal is if there's something you want to do on OpenPower, IBM is making a lot of effort to make it work on OpenPower systems and make it work as fast as possible. Because aside from the functionality, there's performance. And the goal essentially is whatever the benchmark number is versus Intel, we want to be 2 times. So if it's throughput of whatever number, we want to be twice that. If it's price performance, you want to be twice that. And that's drilled into us every single time we go to a new project. Well, this is what we know that it compares the reporting on Intel, right? On these AWS instances with these certain characteristics, we need to be twice that. So, and we look, our job is basically, my team's job is to, for analytics software, well, where are we spending our time? How can we alleviate it? And move from there. So in general, out of the box, depending on how much optimization is done, if it's a pure Java application, we do pretty well. If there's a lot of sim vector optimizations, it takes a bit more effort. But it's usually not too difficult in order to get the 1.5 times performance benchmark. 1.5 times X is usually not too difficult. 2 times 1, because there's a lot more optimizations now on the Intel side, is a bit more effort, but it's definitely possible. And once we get to machine learning, deep learning, with GPUs and NVLink, then Intel is not even there because their processors, the GPUs just can't get data that fast to process. So essentially that's it. So I guess the main caution is, if you download binaries on the internet and try to run OpenPower systems, they may be a little Indian, but they're not going to work. So you need source code to recompile, and as mentioned, IBM spent a lot of effort putting source code to compile easily. And prior to OpenPower systems, for Power 7 and earlier, there's a version of Linux called Big Endian Linux. And for Power 8 and newer, Power 8, Power 9, and so forth, the version of Linux is Little Endian. And endianness refers to how data is ordered in memory. So Power processors, since Power 4, runs in Little Endian and Big Endian modes. But until Power 8, no one has bothered to write a Little Endian operating system for it. So it's functionality that was built, been carried around in silicon for the last 10 years, but no one's done anything with it. And now companies are actually getting around to using the silicon that's been built into it. So I think that's it. So in summary, there's a vast software ecosystem that's provided by Linux, tons of software, open source software packages available. They all are essentially right now, fully supported on Power. And for packages that aren't supported, I can't think of many right now. Well, I can't think of any right now that don't compile and run on Power. There's lots of forums, developer works I can contact, and we're fairly proactive about addressing those issues. So yeah, that's about it. And does anyone have any questions?
Yeah, is this being offered on your public cloud service offering, through BlueStack or BlueBox?
Bluemix?
Platform as a service? Yeah.
Yes, so.
Can you please repeat the question?
Oh, the question is OpenPower systems available on the IBM public cloud? And the answer is yes. I believe the cloud provider that IBM purchased a number of years ago was SoftLayer. And I believe just this month it got rebranded as part of Bluemix. So you can go softlayer.com or ibm.com/Bluemix, and when you can get a VM. There used to be free. When it first came out, I got free VM to test it out, essentially, because people need to test it out. And it went through marketing channels to approve it and everything, like someone external would. But I'm not quite sure what the case is now. But so IBM is available. Rackspace used to have it available. They've stopped. There is there's two other cloud providers I know of that currently have OpenPower on the cloud. Big Vessel, Super Vessel was one, and I can't remember the other one.
I was particularly interested in the fact that you say Spark runs on it.
Oh, Spark? Yes.
Yeah, so which means Spark will run in your virtual cloud.
Yes.
Okay.
Yeah. So, yeah, again, in the software system, well, it runs on any OpenPower system. So whether it's on-premise or public cloud, it will run. Okay. So any other questions? Yes?
Earlier you mentioned that you said Linux was the bootloader, the OS, and the stack. Could you elaborate more on the bootloader setup?
Okay, I guess Linux is probably not quite term. I think the bootloader name is Opal or something, and OPL or OPAL, and I know it's down. I looked at the GitHub link before, but I've never actually was interested in compiling it.
It's the Linux kernel.
Yeah, is it Linux kernel?
It's the
Okay.
Linux kernel. It's the Linux kernel used to kexec into another kernel.
Ah.
Yeah. So
The Oz Labs group, I believe, worked on that.
has I?
I believe so.
Okay, but yes, I was involved in testing, performance testing, the initial bring up, but after the DD 2.1 chips shipped, I got put on to Spark, so I never actually saw that to GA. But yeah, as far as I know, if everything is open source, the entire stack.
So do you just install the Opal to the beginning of the hard drive like a BIOS machine, or is there?
I have to say, I'm not entirely familiar with that.
Opal is firmware. So
Firmware.
it's installed on the board.
Okay, motherboard BIOS.
Yes.
Oh.
So,
That's my understanding, at least.
yeah, yeah. When changes had to be done, at this point during the bring up, all the system lab engineers did all the work. Since I'm in Toronto and the machines were all in Austin, I just called one of the engineers and they did software upgrades. So I'm not entirely sure how that's done. Yes?
Within Canada, who sells OpenPower systems?
Okay, so the question was, within Canada, who sells OpenPower systems? That's an excellent question, and I'm not on the marketing side. I know IBM.com, and I believe that last time I checked, the cheapest OpenPower system on IBM.com was roughly $5,000 US. But there was, Tyan had a $2,000 system available for a while. And again, that's FOB from Hong Kong or Singapore. So shipping is extra on top of that. But I'm not sure. IBM.com sells IBM branded OpenPower systems, but I would have to look, see who else sells it. Red Power sells it, Tyan sells it, Supermicro, but I'm not sure whether within Canada or them online. Yes. Any other questions? Yep.
In terms of alternate architectures to x86, obviously there's ARM, which is sort of growing up from the small end into
Yep.
the larger space, and Power, which seems to be going a little bit down from the high end and a little bit lower.
Yep.
Are there any projects in the works that would lead to a less expensive, more basic development system or board that could be used, for example, for teaching or for an individual developer that wanted to get familiar with Power?
That was the Tyan system. I think Tyan, the $2,000 system was their education learning platform.
Okay.
So I just saw a press release when it came out. I checked, it was there, but I haven't done anything with it since.
I was just wondering more along, 96 boards, Raspberry Pi.
Oh,
price
really?
points,
Oh,
so that a student could buy that instead of a textbook in a course dealing with OpenPower.
no, I don't think so. I think the aim is really more towards mid and high range,
Right.
because the distinguishing features from OpenPower is the fact that all the high-end performance I/O, essentially. Google's primarily interested in Power 9 systems because the I/O capabilities. The processing capabilities, they can tune Intel, they can buy more Intel boards. I mean, there's no real need to buy a Power 9 system if the claim is twice as fast as Intel. They can just buy twice as many Intel systems and only support one platform instead of two. But with OpenPower system, they can run these GPU applications, which they can't on Intel as effectively, right? And they can't run for faster, for example, all these CAPI systems with lower latencies and such, they can't run that on Intel systems. So those, even though the technology is open source, the cards that support it are not very cheap. I think that each P100 board, I see, OEM prices are about $9,500 to $12,000 US each. So those servers with four P100 systems, it's $60,000, but I think $45,000 that goes to NVIDIA, right? So IBM gets $100 or so for licensing, and the rest goes to system manufacturers in Asia. So majority of the money made for that system goes to NVIDIA. And you can buy a small board, but you can't get those capabilities. So you can learn how to program on Intel, but if you need to scale up your system, whatever software developing on Intel, you can bring it, once you're ready, to a high-end system and run it there. So that's essentially the angle that I think IBM is aimed towards. So if you're dealing with some Intel, you want to run on a higher platform, you can bring it to power. So, and with that, any other questions? Okay.
Thank you very much
Thank
for
you.
your presentation.
Thank you.
It was very nice. Thank you very much.